Bending of light rays as they travel from one medium to another. Place a pencil in an empty beaker and look at it from the side. Add water in the beaker till it is about half full. What do you observe? The pencil seems to be bent at the surface of water and its tip appears to be raised. This happens due to the bending of light rays as they pass from air to water. Bending of light rays as they travel from air to water. Take an empty cup or a beaker and place a coin at the bottom. Now position your eyes such that the coin is just not visible and is obstructed by the edge of the cup or beaker. Now ask someone to gradually pour water into the beaker without disturbing the coin. What do you observe? You will observe that as the water level rises, the coin becomes visible. You know that you can see an object only when rays of light from an object reach your eyes. When the coin is not visible to you, the rays of light do not enter your eyes. As soon as water is poured into the beaker, the rays change their direction and the coin becomes visible. The rays of light on emerging out from water bends and reaches your eyes. It now appears to be coming from K instead of R. The coin appears to be raised to K and becomes visible to you. Refraction of light through a glass slab. Fix a sheet of white paper on a drawing board. Put a rectangular glass slab on it and mark the boundary ABCD with a pencil. Fix two pins P and Q on the longer side of the slab so that the pins are vertical and the line passing through PQ meets the slab obliquely. Look for the images of the two pins from the opposite side CD. Fix two more pins at R and S so that these pins and the images of P and Q are in a straight line. Mark the positions of the pins. Remove the pins and the slab. Join PQ and produce it to meet the slab boundary at O. Then PQ is the incident ray. Join SR and produce it to meet DC at O'. Then RS is the emergent ray. Join O'. O' is the refracted ray. Draw the normal NN' passing through O perpendicular to AB and MM' passing through O' perpendicular to CD. Angle PON is the angle of incidence. Angle O'N' is the angle of refraction and angle SO'M' is the angle of emergence. Now measure the angle of incidence I and the angle of refraction R. You will notice that angle R is less than angle I. Refraction through a glass prism. Draw an outline of a prism on a white sheet of paper. Fix two pins P and Q from the incident ray and draw a normal at A when the incident ray meets the face XY. Look through the other side of the prism and fix two more pins R and S in line with the images of P and Q. Remove the prism and pins and draw the emergent ray RS. Extend the line backwards to meet the prism outline at B. Join AB. AB is the refracted ray. Mark arrowheads to indicate the path of light from P to R. The path PQ ABRS shows the refraction of the ray PQ through the prism. The ray PQ undergoes two refractions, one from a rarer medium to a denser medium at A and the other from a denser medium to a rarer medium at B. As a result, it bends twice and ultimately emerges out of the prism, bending downwards towards the base of the prism. The angle between the incident ray produced and the emergent ray produced is called the angle of deviation, d. Dispersion of light. Allow a very narrow beam of white light to fall on one face of a prism. Hold a white screen on the other side so that the light emerging out of the other face falls on it. What do you observe on the screen? You will see that the white light has split up into 7 different colors on the screen. The colors are in the following order: violet, indigo, blue, green, yellow, orange, and red. These colors can be remembered by a word, vibgyor. Violet is the most deviated and red is the least deviated. These colors resemble those of a rainbow.